meets our needs for what you're going to be responsible for in the coming months to make this transition to 512 math class. So, factoring is a polynomial. And it's my understanding that we are all learning polynomials right now in 516 class. What is a polynomial? My class just took a quiz. I'd love to hear from one of them. What's a polynomial? Is it an equation?
No.
No.
Then what is it?
Isn't it like how many numbers there are in an answer or something?
It has something to do with numbers.
Knew it.
Isn't it like 4 on like terms, kind of?
It is terms. It's an expression. It doesn't necessarily have to be 4. It could be 1, 2, 3, 4, or more. It's an expression, or perhaps just a number. All right, a number could be a very, very simple polynomial, but it's a polynomial that, when multiplied, by other factors, they produce a desired result. All right? This is going to be our working definition for a factor. It's a polynomial, which could be some sort of an expression or just a number, that when multiplied by other factors produces a desired result. Simple example. I want to know some factors of the number 12.
To the main office, please. Kirsten, Curvin, to the main office.
Factors of 12. I heard two answers over here. I heard a 3 and a 4, right?
Yes.
3 and 4.
6, 2.
If I multiply them by something, it'll give me 12. 6? 6 and 2. Another one? 1 and 12. Have we exhausted them?
Yeah.
Well, there's many other numbers that I could multiply to get 12, but they wouldn't be whole numbers. So those would be our integer factors of the number 12. Together, with the combination of them, I can multiply and get the number 12. GCF, abbreviation, greatest common factor. My guess is you probably did some of this in previous courses, figuring out what's the largest number that goes into both of our desired results. 12 and 45. What's the biggest integer you can think of that can be divided evenly into 12 and into 45? Yes, sir. 3. Does 3 go into 12? Sure does. Does 3 go into 45? Yes. I agree. 3 is the greatest common factor of those two. Second example. Greatest common factor of 12xyz and 45xy. What is the greatest compilation of numbers and variables that these two terms have in common? Yes, young lady. 3xy. What would I have to multiply 3xy by in order to get this desired result? What would I have to multiply by? What? Z and something else. 4. I'd have to multiply by 4z, and I would get that desired result. What would I have to multiply 3xy by to get that desired result? One more time. By 15. That proves it's a factor. Greatest common factor, 12x squared, y to the third, z to the fourth, and 45x, y to the sixth, z to the second power. What is the greatest common factor, or the greatest compilation of numbers and variables that both of these expressions, or both of these terms have in common? What do you got?
3.
What's the greatest number of x's they have in common? 1. How about y's? What's the greatest number of y's they have in common? So y to the third. And how about z's? Z to the 2. There is our greatest common factor for those two simple expressions. Right? They're one one-term polynomial. Let's get into factoring. I call this phase one factoring because it is the easiest. And in the hierarchy of things you want to try, this is where you want to begin. You won't always be able to factor in this manner, but if you can, this is where you want to begin so you avoid some of the more complex methods. Here is a 1, 2, 3-term polynomial. What do we call a 3-term polynomial? It's a trinomial. 1 term, 2 terms, 3 terms. What is the greatest common factor of those 3 terms? Yes, sir. 7. What would I have to multiply that 7 by to get 35x squared? 5x squared. What would I have to multiply my 7 by to get a product of negative 14y? Negative 2y. What would I need to multiply my 7 by to get a product of 84xy? 12xy. 7 multiplied by this trinomial will give me my desired result. Therefore, it must be a factor. Again, a factor is a number or a polynomial that when I multiply it by something else will provide me with a desired result. If I redistribute, that will be my desired result. Number 2, it looks very much the same except now I have added in a few more exponents. What is the greatest common factor in number 2? What do you got? 7 again? Any x's or y's that I can put into that greatest common factor as well? Yes, young lady?
X and Y?
X and y? Just to the first power?
Yeah.
Okay. What would I have to multiply 7xy by to receive this desired product of 35x squared y squared? Yes?
5XY?
5xy. How about that middle term? What would I need as a middle term of my trinomial here to get that as a desired result? Jerry.
Negative 2x.
And what about the third one? Marina, what about the third one?
12.
Just 12?
Yeah.
There we go. Now we have 2 factors. I've got my monomial factor, 7xy. I've got my trinomial factor, 5xy minus 2x plus 12. I multiply them together, I get my desired result. Number 3 is smaller. I don't know if that means it's going to be any easier. X squared, 6x. What do they have as a common factor? Rowie.